Here's the solution to problem 13, Engineering 1301, final exam, summer 2020. All right, so this is a gear problem, and as we know, there's a driving gear, and you need to make it where the driving gear, imparts a torque onto the driven gear. All right, so we're starting with the driving gear. It's given in the problem statement that gear A is connected to the electric motor, so that's clearly the driving gear. All right, and it has from the motor 2 foot-pounds of of torque. All right, so at shaft A you have this torque, and you're imparting a change in torque using a gearbox that's shown with gears A, B, and C. All right, so I'm looking at this, and because the moment arm for A is bigger than the moment arm of B, you're reducing the torque. All right, another way to think of it is the teeth on gear A are moving at a certain speed. All right, and so maybe you can visualize that if you have a certain speed for gear A, gear B is going to be going faster because it's traveling the same distance with the interaction of the teeth. Okay, so if you spin faster, you have a reduction in torque. All right, so we look at these gear ratios, and that's the key. So the torque at B is 30/40, the gear ratio between gears A and B. All right, so 30/40 tau B. And because we're saying these aren't ideal gears, all right, the place where you incorporate the efficiency of the gear is with the torque. All right, so that's 0.8 for that number, and so you can calculate the torque at shaft B. All right, doing the same thing at C. Again, we're going from a bigger gear to a smaller gear, so we have a reduction in torque and increase in speed. Okay, so I plug in tau B, which is known. That goes in here. We take care of the efficiency, 0.8, and we end up with this for the torque at shaft C. Okay, so we're reducing the torque. All right, what we're picking up though is speed. All right, so let's go through the speed calculations. If we start at a speed of 100 RPMs, all right, we know if we have a bigger gear driving a smaller gear, it's going to result in an increase in speed. So we take 40/30 times omega A, and we see that the RPM has increased. Same thing happens on the next gear. We have a bigger gear driving a smaller gear, will result in an increase in speed. So omega C is 30/10. You take a look at those gear ratios of omega B, and so our final speed here is 400 RPM. All right, so we're constrained by the teeth on the speed. So efficiency doesn't affect the speed. What it affects is the torque. All right, so that's important to know in these kinds of problems.